And again, hello and welcome to today's webinar, Storage with Amazon S3 and Amazon Glacier. Our presenter today is Daryl Osborne. Daryl is a storage specialist solutions architect for AWS storage services like Amazon S3, Amazon Glacier, Amazon EBS, Amazon EFS, AWS Storage Gateway, and AWS Snowball. His focus is on helping customers design, build, and optimize highly scalable, durable, and available storage solutions leveraging AWS's cloud services. Today with us, we also have Lex Crosett, Lee Kier, and Peter Levitt, who will be our webinar moderators in answering your questions throughout the presentation. Daryl, welcome. The floor is now yours.
Great. Thank you, Jerry. I appreciate that. So thank you, everyone, for joining us today. You know, I recognize your time is valuable, and I appreciate you spending the next 60 minutes with us learning about more about our storage services here on AWS, specifically Amazon Simple Storage Service and Amazon Glacier. As Jerry mentioned, my name is Daryl Osborne. I am a storage specialist solutions architect with AWS. So many of you may be wondering, well, what does that entail? So, you know, I help customers design, build, and optimize highly scalable, durable, and highly available storage solutions using the AWS cloud, specifically Amazon S3 and Amazon Glacier, which we're going to talk about today. But first, what I'd like to do is really talk about our platform, our full suite of storage services. We'll dive a little deeper into some of our core storage offerings like Amazon S3 or Amazon Simple Storage Service, as well as Amazon Glacier. And Amazon Glacier, as some of you may know, is a low-cost, easy-to-maintain storage tier that is really used for deep archives or long-term backup. Think of it as, really as cold storage, hence the name Glacier. We also have a number of data transfer options available to ingest data into AWS, along with our content distribution network service, which is Amazon CloudFront, and we also have. We'll talk a little bit about some of the use cases. We'll present 2 use cases for you, and then we'll finish off with some Q&A. So at AWS, we have a full array of different storage platforms. So regardless if you need file, block, or object storage, we've got you covered. First, we have file storage. So just to level set everyone listening or watching today, with file storage, you typically have a network-attached storage device or a NAS device connected to a network that provides file-based storage to either users or devices on that network. At AWS, we offer Amazon EFS, or Amazon Elastic File System. And this provides a simple, scalable, managed, full file storage as a service for users within AWS, and specifically to Amazon EC2 instances. And it's based on the NFS protocol. Next, we have block level storage, and that's typically used in SAN environments, storage area network environments, where data is stored in volumes, and they appear to computers' operating systems as a local hard drive. This is good for running operating systems or file systems. At AWS, we have 2 different offerings in the block platform. First is Amazon EBS, or Amazon Elastic Block Store, which is a service that provides persistent block level storage volumes for use with Amazon EC2. So you attach an EBS volume to an EC2 instance and use it as if it were local storage to that virtual machine. This is where you would put the operating system or file system, and a single EC2 instance can have multiple EBS volumes attached. EBS volumes can persist beyond the life of the EC2 instance. So you can detach it from that instance and attach it to another instance so you can get access to that volume. Some EC2 instances have what we call instance storage, and this is our second block offering. Instance storage is local to that instance, and it persists only as long as that instance is alive. Therefore, we recommend that you only use local instance store for those temporary objects. Think of it as ephemeral storage. Next, we have object storage. And the two object storage offerings we have on this platform are Amazon S3, or Amazon Simple Storage Service, which is a service that provides developers and IT teams a very secure, durable, and highly scalable cloud storage. It's easy to use. We have a simple web interface to store and retrieve any amount of data from anywhere on the internet. We also have Amazon Glacier, which is a secure, durable, and extremely low-cost cold storage service. So it's also object-based, and it's really used for data archiving and long-term backups. S3 and Glacier are two of the storage services we're really going to focus in on today, and we're going to dive deep into these in a few minutes. But storage is more than just a protocol or an interface. It's really the lifeblood of application design and renewed architectures. You, our customers, have taught us that you're really looking for two things. You're looking for scale and trust. First, you want to make sure that you can grow, that it can scale out to your needs. And second, you want to make sure that you can access the data when you need it. And of course, you want to keep your cost as low as possible. And we also have a suite of transfer services that support our customers migrating their data to the cloud. And we want to give you as many choices as we can. So depending on if it's large batches or incremental changes or maybe constant streams or seamless integration, all of these are different offerings or ingest offerings that we have to help you ingest data within AWS. So first, let's explain a little bit about what block storage is. So block storage is a system for storing files as opposed to a file system. It has a flat hierarchy and a namespace, and it stores the file metadata along with the file. And those two things together make up an object. And some of the advantages of this approach to storing files as objects is really increased durability, low cost, and the ease of management and scalability. With Amazon S3, it is an object store delivered managed service. It's very mature. It's actually one of the first web services that Amazon released about just a little over 10 years ago. And it's used in just about every imaginable file storage use case out there. Some of the very well-known customers that rely on Amazon S3 include customers like Dropbox, Pinterest, Airbnb, and even Netflix uses Amazon S3. So it integrates with other AWS services to really simplify the uploading and downloading of data. And it makes it very easy to build solutions that use a wide range of AWS services. So it integrates with our compute platforms, with EC2 and Lambda. It also integrates with our analytic platforms like EMR or Elastic MapReduce platform, data pipeline. It also integrates with our content delivery infrastructure, so our CloudFront network, and even has ties into our Elastic Transcoding service. Big data is also very important, and we have big data as well as database services can leverage Amazon S3 and Glacier within their solutions and within their architecture. So we have a number of customers running a wide variety of applications and workloads that frequently access data stored within Amazon S3. So, customers around the world really depend on Amazon S3 and Glacier to safeguard their objects. And we have customers, all the customers around, we actually have trillions and trillions of objects stored in Amazon S3. It is highly durable. Today we have 14 regions around the world. And we also include a geographic redundancy operation service to help replicate data across regions. Our AWS storage services really include a number of different methods to help you ingest data into the cloud. But it's not only just ingest, it's also egest, basically getting that data out. So we want to make it very easy for you to use your data because you retain ownership of that data and you retain really the ability to control who has access to that data when it is in the AWS cloud. Objects may be moved between storage classes in a very customizable and automated fashion. We realize that data has a life cycle of its own. As data is initially created, sometimes it may be considered very hot, depending on the type of data. It may be hot, meaning that it's going to be frequently accessed. Well, over time, the temperature of that data may drop, and access may drop down. So it may be considered then warm data. And eventually that data would drop down to what we consider cold data or maybe archive data, where it's very infrequently accessed, but you don't want to lose that data. You want it to be very durable. So there is a life cycle of data, and we want to make it very easy for you to put data in and have it actually go through that life cycle automatically. As I also mentioned, we have a broad integration with other AWS services. It integrates with our AWS IAM, or Identity and Access Management System, to control access of who has access to that data and who can create new data, who has access to your buckets within Amazon S3. It also integrates with our key management system or service, which is KMS. We also have alerting mechanisms, with CloudWatch and CloudTrail and event notifications, where you can create notifications or workflows based on certain events that will happen within your bucket. And it's also designed to integrate with a lot of our database platforms and systems. So let's go ahead and dive very deep into Amazon S3. So as I've already mentioned, Amazon S3 is easy to use object storage. We provide a simple web service interface to store and retrieve that data. Data or objects are stored within a resource that we call buckets. And you can store as many objects as you want within a bucket. Within this bucket, you can grant users the ability to read, write, or delete objects. Objects can be up to 5 terabytes in size. And you have the ability to view access logs, so you know who is accessing your buckets and these objects within the bucket. You also identify the region that your bucket is created and where your data is going to be stored. You really do this to optimize for latency. A lot of times you want to get your objects as close to your end users as possible to lower that latency, to possibly minimize cost, and you may need to address regulatory requirements. S3 scales really without limits as well. So you can store as much as you need, and you can access it whenever you need to. It is extremely durable, and you can store your most important data in Amazon S3. It is designed for 11 nines of durability, and your data is redundantly stored across multiple facilities and multiple devices in each facility. And it's designed to sustain a concurrent loss of data in 2 facilities. So it is extremely durable. It allows you to store large amounts of data at a very low cost. And using lifecycle management, you can actually set up policies to automatically migrate your data as your data ages. And you can do this into different data classes or tiers, like going from S3 standard to S3 standard infrequent access, then all the way down to Amazon Glacier. So you can do this to further reduce your cost within AWS. And with all of our services, you pay for what you need. There are no minimum commitments and no upfront fees. As you know, security is our #1 priority at AWS. So data stored in S3 is secure by default. Only bucket and object owners have access to the Amazon S3 resources they create. So it supports multiple access control mechanisms, as well as encryption for both secure transit and secure storage at rest. With Amazon S3 data protection features, you can protect your data from both logical and physical failures, guarding against data loss from unintended user actions, application errors, and infrastructure failures. For customers who must comply with regulatory standards, such as maybe PCI or HIPAA, S3's data protection features can be used as an overall strategy to achieve some of these compliance requirements. So your data is important. We understand and we know that. For many of you, it is really the lifeblood of your organization. So we want to give you a feature-rich service with tools you need to manage your data efficiently. So just like the name implies, Amazon's simple storage service is simple. It is easy. It is easy to use. We give you a web-based management console. We also give you a command line interface. We give you a full REST APIs and SDKs so that you can build your own applications or integrate with third-party tools. So some of our customers wanted to be notified or maybe kick off a workflow when certain events happen within an S3 bucket, like maybe when objects are created or deleted. Well, you can do this and even more with event notifications. We'll dive a little deeper into that a little later. As I already said, data protection and security is our #1 priority. So we want to provide you the tools to protect your data. By enabling versioning, as an example, you can protect against accidental deletes. And with cross-region replication, you can have your buckets automatically replicated to another bucket in a different region for disaster recovery purposes, maybe business continuity, or for regulatory compliance. We also have a feature called MFA delete. And by enabling MFA or multi-factor authentication delete, you require another layer of security, really an additional authentication mechanism in order to delete objects. You also have the ability to set up flexible policies to control who has access to your objects, along with when they'll be able to access them. And all this information, who is accessing the data and when, is available to you in access logs, and they are delivered to you in S3 buckets. We also offer multiple client and server-side encryption options, including AES 250-bit encryption. So throughout the years, we have continued to innovate and add new features and exciting features to Amazon S3. So I want to highlight just a few here that we've added over the years. And a little later, we'll dive into these a little deeper. Some of our customers, as I mentioned, they want to be notified of certain events. So with event notification, they have the ability to be notified either via SNS, or Simple Notification Service, SQS, which is our simple queuing service, or Lambda. They could be notified or have a workflow or some type of function automatically kicked off when a certain event occurs within your bucket. We'll dive into that a little deeper as well. In order to make it easier for you to make copies of your S3 objects in a second AWS region, we offer cross-region replication. So with this feature, it enables you to comply with possibly stringent regulatory requirements for storing sensitive data that could be maybe financial or personal in nature. And once enabled, every object that is uploaded into a particular S3 bucket is automatically replicated to a designated destination bucket in a different region. So that's a great feature if you want to, keep your data within a certain geography, maybe here within North America, but you want to have your data maybe a little closer to end users, maybe on the West Coast or on the East Coast. This allows you the ability to then replicate that data between two different AWS regions. You can access Amazon S3 from within your VPC using VPC endpoints. And Amazon VPC endpoints they're easy to configure. They provide a reliable connectivity, a solution to Amazon S3 without requiring an internet gateway or a network access translation and NAT instance. Basically, it gives VPC endpoints and it gives EC2 instances the ability to transfer data to and from S3 buckets without going over the internet. Amazon CloudTrail is a web service that allows you to record AWS API calls for your account, and it delivers those logs to you. With CloudWatch, it's a monitoring service for your AWS resources and even applications you run within AWS. Both of these services are integrated with S3, and you can use CloudWatch, for example, to monitor your S3 buckets, tracking metrics such as object count or maybe byte stored. And with CloudTrail, bucket level operations are made available to you so you can track the creation, maybe deletion of buckets, modifications to access controls, changes to lifecycle policies, or even changes to cross-region replication settings. So all of these actions are made available to you using CloudTrail. By default, you can create up to 100 buckets in each of your AWS accounts. And if you need more buckets than that, you can request an increase in your bucket limit by just submitting a service limit increase. And last year, I believe it was last year, we changed the data consistency model for our US standard region. You may know this today as the US East 1 region. So last year, we added read after write consistency for new objects added to S3. So just in that region. Prior to that, all regions except for US standard supported read after write consistency for new objects. But now with this enhancement, S3 supports read after write consistency in all of our regions for new objects that are added. So just for you that may not be familiar with the read after write, what that is, read after write consistency really allows you to retrieve objects immediately after creation. And prior to that, with our distributed model that we had in US standard, it may take some time to distribute that object to all of the facilities. So on occasion, if you put an object, you may not be able to retrieve that object immediately. But now with this new feature, read after write consistency, as soon as you put that object, you're able to read that object in all of our regions. So throughout the years, we receive a number of requests and feature requests from our customers. And one enhancement that we've made recently is adding the ability to have a different storage class or tier. What we call this is we have Amazon S3 Standard IA or infrequent access. And that's a different storage class for less frequently accessed data. But this data, you also need rapid access to it. So it's not like Glacier where it could take hours for you to get access to that data. With S3IA, you have immediate access to that data. Again, it is just like Amazon S3 standard, so you have high durability, you have the throughput, and you have the low latency as you have with standard. You also have a low per gigabyte storage cost with it, but you also have a per gigabyte retrieval fee. So that's one thing that sort of differentiates it from S3 standard. So this combination of low cost and high performance really makes a standard IA ideal for long-term storage, even backups, and as data stored, for disaster recovery or business continuity. This is a great storage class for those types of data. IA, so objects that have a storage class of standard IA can exist in the same bucket as those objects stored as S3 standard. So it allows you to use lifecycle policies to automatically transition objects between different storage classes without making any changes to your application. We've added 2 lifecycle policies recently, expired object delete marker and incomplete multi-load upload expiration. So with multi-part upload feature, it really improves your put performance by uploading parts of a large object in parallel. With the multi-part upload, if it is not completed, the partial upload does not appear when you list out your objects by default, but those incomplete objects still incur storage charges. So previously, you needed to manually cancel the multi-part upload and remove these partial uploads. But now you can set this lifecycle policy to automatically expire incomplete multi-part uploads after a predefined number of days. So that's a great new feature that we see a lot of customers starting to leverage. Also, S3 bucket versioning feature helps you recover from unintended user deletes or even application logic failures. So when you delete a versioned object, a delete marker becomes the current version. This is how we manage deleting an object with versioning enabled. So when you delete an object with versioning enabled, a delete marker really becomes the current version. And the original is just retained as the previous version. So while you're not charged for storing these delete markers, removing expired markers can actually improve performance when you do list commands, when you submit list requests in your bucket. So now you can set a lifecycle policy to automatically remove the current version delete markers when previous versions of that object no longer exist. So a great way to improve performance. So Amazon S3 supports multiple levels to help transfer large objects into and out of the cloud. So one of the simplest methods and features that our customers are starting to use is Amazon S3 Transfer Acceleration, which really combines an innovative software layer, protocol optimization, and our AWS Edge infrastructure, our locations. And I believe now we have about 64 Edge locations around the globe. And we use this to accelerate the data transfer. We've seen up to 300% improvement than on, say, an existing infrastructure when uploading and downloading S3 objects. So by simply enabling this feature within the console and changing your S3 bucket endpoint name within your application, your Amazon S3 uploads and downloads will be accelerated without doing any adjustments to protocol or any changes in the firewall or buying any acceleration hardware devices. So one of our customers, Huddle, said this. So Brian Kaiser, who is the CTO, said this about transfer acceleration. Amazon S3 transfer acceleration reduces the average time it takes for us to ingest videos from our global user base in almost half. This gives our customers the ability to edit and share video sooner, where speed is a critical factor. We loved how easy it was to get started with transfer acceleration. Just a simple endpoint change in our application and done. All this for a fraction of the cost of the solution we evaluated before. So a great feature, we encourage you to test it out. You can actually test it out for yourself by going to the accelerate-speed-comparison page, where a speed checker will actually use a multi-part upload to transfer a file from your browser to various S3 locations around the world and compare and show you the results. So you'll know if transfer acceleration is going to help you with your workload. So if you think about, a typical life cycle of your data, newly created data is accessed very frequently. We consider this data hot. We could take an example. Take a new video. Say you have a video clip you want to share with your family and friends. Initially, everyone's going to be viewing this all the time. People are going to be playing it back. They're going to be sharing it. They're going to be commenting on it. So it's going to be accessed very frequently. So we're going to call this hot data. So the best location for this data would be Amazon S3 standard. But as time goes on, the video is going to become older. Interest is going to die down. I know you would think that our videos are so great that everyone will want to watch it for forever, but that's really not the case. So, interest is going to die down. It's not going to be as hot as it once was. A smaller number of people are going to be viewing it and sharing it. So it's going to be less frequently accessed. So we would consider that perhaps warm data. So with warm data, we would want to put that into S3 standard infrequently accessed data. And that is a low-cost storage class within S3. And it's really designed for data that is infrequently accessed. Again, it has the same great durability and performance as Amazon S3 standard, but with a slightly lower availability. It's ideal for workloads that are a little colder than hot. Maybe call it warm. And it's really for data that is less frequently accessed. So if you don't want to think about your data access patterns and you want to just have high durability, availability, and performance, you can simply put your objects into S3 standard. But for data that is less frequently accessed, you can leverage standard infrequently accessed storage class to save on a little of the cost, and you can benefit from still the great durability and performance that S3 standard has. But over time, your data, this video as an example, the interest is going to completely drop off, and the data is going to become cold. And no one is actively going to be interacting with it. No one's going to be viewing it or sharing it. But again, you still want to keep that data around. So you want to archive it. You want to archive that off. So in this example, you can actually have a life cycle that will move that object all the way over to the Glacier storage class. And there you can take advantage of the very low cost per gigabyte associated with Amazon Glacier. So this is how we would see an object move through the life cycle. Again, very active data can be stored in Amazon S3 standard class. As it becomes a little colder in access activity, you could then store that in S3 standard infrequently accessed storage class. Then eventually you'll want to archive this data off. And there you would want to archive it in Glacier. So let's walk through a little example of what this would look like. So here we have hot data. It's great for data that is accessed all the time. It's even good for temporary data, maybe data that isn't going to stick around for more than 30 days. It's going to be here for up to 30 days. S3 standard, great place to put that data. As data becomes less frequently accessed, you'll want to then lifecycle that off to a different tier. In this case, you'd want to move that off to infrequently accessed data, and then as the frequency of that data access completely drops off and you just want to keep it as an archive, you would then move that off to Glacier. So some of the benefits of S3 and S3 infrequently accessed data is there's a common namespace. As I mentioned, within one bucket, you can have your S3 standard objects and your S3 infrequently accessed objects. Again, it is secure. You can control access to that data using S3 bucket policies, by using identity and access management, and that data can be encrypted using client-side encryption or even server-side encryption. You can have event notifications when objects are maybe created or deleted within your bucket. You can enable versioning on that as well, so that you can keep multiple versions of that object, so that an accidental delete doesn't completely wipe that data off. Because remember, it doesn't matter how durable Amazon S3, 11 nines of durability. If you delete your data, your data is gone. But if you enable versioning and you delete that data, a copy of that data is always there, just as a different version, and you have access to that. So basically, think of it as a recycle bin that you can clean out eventually. And you can clean that out with the lifecycle policy. You also have cross-region replication. So you have the ability to then move that data from a particular bucket in one region to a destination bucket in another. And you can do that for a number of reasons, maybe compliance or regulatory reasons. Maybe you want to get your data closer to the end user. So that's one of the options that you have. You have that lifecycle ability, so you can basically move that data from one storage class to another. Again, 11 nines of durability for our storage classes here. The availability with the Amazon S3 standard is 4 nines. The Amazon S3 infrequently accessed is 3 nines. Again, very low latency, high throughput performance infrastructure, and it scales. Again, you can load as much data as you want within your S3 buckets. So if we take a look at pricing, hot data is in S3 standard is priced at 3 cents per gig per month. And as we look at the different pricing tiers, infrequently accessed data is priced at 1.25 cents per gig per month. So you can see there's a substantial reduction in price. So depending on your access patterns, depending on how you're using your data and how important that data is, it may make sense for you to life cycle that data off from S3 standard to S3 infrequently accessed storage class, and then eventually to the Glacier storage class to really keep around for a long-term archival, sort of a long-term backup solution. So data that is sized anything over, say, 0 kilobytes, any amount of data, you could put that in Amazon S3. With Amazon S3 infrequent access, you are charged, the minimum size is really 128 kilobytes. So if you have an object that is less for that, you are still charged for 128 kilobytes of data. So you want to keep that in mind. So depending on the size of your data, and even when we get into this, how long that data is going to live really depends. That will help you determine which storage class to store your data in. If your data is going to live less than 30 days, we recommend that you put it in an Amazon S3 standard, because Amazon S3 standard infrequent access, there is a minimum duration, life of that data, which is 30 days. So even if you put it in for 2 or 3 days, you're going to be charged storage for that object for 30 days. And then with Amazon Glacier, again, any size object can go into Amazon Glacier. There is a 3 to 5 hour waiting period. So when we've talked to our customers, and one of the reasons we came out with Amazon Glacier is because they wanted a low-cost archival solution, but they told us they didn't need immediate access to that data. So that's why we created Glacier. So there's a 3 to 5 hour window in order to retrieve that data. And so think of it as possibly a tape replacement solution. Typically today, if you needed to retrieve tape from off-prem, maybe to an Iron Mountain or some other facility, it would take you hours and hours, maybe even the next day, to retrieve that data. Think of it like that, but it's a little better. You've got a 3 to 5 hour limit, and then a time period, and then you have access to that data. So let's go through a couple of use cases. So here with, say, SmugMug or Prezi. So with these use cases, data that is ingested into these services, into these solutions, typically becomes very dormant, closely, soon after it was uploaded. So the access pattern is usually, 90% writes, 10% reads. So this is a great example of, initially you want to put that data into Amazon S3, but then as time goes on, you want to lower your cost. You want to move that data over to Amazon S3 Standard infrequent access so that you can lower your cost. But again, you still have the immediate access to that data. Here's another example for SoundCloud and Sony. Again, data that is active, you want to store in Amazon S3 Standard. Then as the frequency of that data, the access of that data drops, you want to move that data off to S3 infrequent access. Then eventually you want to archive that data off to Amazon Glacier. And one last example here is with King County. So backup and archive of on-prem data is a great use case for putting data both into Amazon S3 infrequent access as well as Glacier. So we have a very large partner ecosystem, and many of these backup solutions do support storing objects, storing your data in Amazon S3 and Amazon Glacier. So by leveraging these third-party products that do support S3 and Glacier as back-end native file or native backups or archiving solutions, you're able to leverage your existing investments in these tools and benefit from storing your data on a highly durable, scalable back-end cloud infrastructure like S3 and Glacier. So let's dive deeper into some of the features that I mentioned a little earlier. So with versioning, you're able to, it really augments the ability to protect your data in case that an object was accidentally deleted by human error or data corruption. So whenever you rewrite an object, we'll keep the previous object there. We'll just give it a version ID. So in case you need to go back to that object to either read it, you can read that object, or you can actually copy that object over the current object, so you have access to different versions. One of the reasons that some of the customers were hesitant to adopt versioning is they were really concerned about limiting the number of objects being stored or the capacity associated with all those different versions. So what we did, we introduced a life cycle policy to support basically versioning your, really expiring those versioned objects. So after a certain amount of time, those objects could just expire, and you wouldn't have to pay the storage costs associated with that. And this is something you can easily do within the management console. With event notifications, you're able to, as I mentioned, leverage SQS and SNS to, and even AWS Lambda to get notified of certain events that happen within your bucket. So if the object is created or deleted, you can have something fire off to either get notified or to take some type of action, have a compute resource take some kind of action to do something. So it's a great example. Would be if you're uploading, say, video files into an S3 bucket, you can have a process that will actually kick off a Lambda function that will create a thumbnail for that object and put that thumbnail within the bucket. You can do this all within S3, Lambda, and event notifications. So with cross-region replication, we've already talked about this. This really gives you the ability to replicate objects in a bucket from one AWS region to another. So as objects are put into that one bucket, they're automatically replicated. It's a one-to-one replication between two regions. And one of the requirements is you need to have versioning enabled on both of those buckets. Amazon S3 VPCE endpoints really gives you the ability to have your S3 objects accessed from your EC2 instances in a VPC without going through the internet. So you have basically private endpoints from within your VPC to those S3 objects. So it really it alleviates your need to access and go through the internet to get access to those objects within a VPC. And we give you lots of different data encryption options. So you can encrypt your objects using client-side encryption, and there's a number of server-side encryption methods that you can use to secure that data. Amazon S3 is available in 14 different locations, and Glacier in 14 different regions today. And there's 4 new regions coming. I just want to mention that I think it was last week or 2 weeks ago, about 9 days ago actually, the Ohio region was created. So US East 2 is now available, and it has some of our storage services like Amazon S3 and Amazon Glacier already available. So you can start using that region today. So let's talk about sort of traditional storage. So if we were to, if we wanted to store X amount of data, say it's 400 terabytes of data within a traditional storage environment, you'd have to come up with, say, a petabyte of raw storage. Of that petabyte of raw storage, maybe 800 terabytes is going to be usable. And you want to allocate 600 terabytes, but you're only going to consume 400. Well, with Amazon S3, you're only going to consume and pay for 400 terabytes of data. And again, you only pay for the data that you use. You don't have to provision all this excess storage. And you also have to remember that that storage, that data stored in S3 is replicated to multiple sites. So take a look at this slide and take that raw storage, now double that or even triple that to have it in different physical facilities. And that's how you would want to compare with Amazon S3. So pricing with Amazon S3 varies depending on the region that you're in, and it varies depending on the storage class that you select. So you can get all that information from our pricing page for Amazon S3. To make it a little easier, we have the simple monthly calculator, so you can actually plug in what you think you're going to be using in terms of storage for S3, and it'll help you calculate that out. So now let's quickly dive into Glacier. So Amazon Glacier is an extremely low-cost storage service that provides secure, durable, and flexible storage for backup and archival data. It really enables you to offload some of those administrative burdens in operating your backup or archiving infrastructure. You really move that over to AWS, so you don't have to worry about capacity planning, provisioning hardware, data replication. So within Glacier, data is stored in archives. It's stored as archives, and these archives are stored in vaults. So think of it as if you compare S3 and Glacier. Within S3 you have objects. Within Glacier you have archives. Within S3 those objects are stored in buckets. For Glacier, these archives are stored in vaults. So a single archive can be very large. It can actually be up to 40 terabytes in size. And again, you can have unlimited number of archives. So really unlimited amount of data you can store within Glacier. It is extremely durable. It has the same durability as Amazon S3 at a very low cost. So basically 7/10 of a cent per gig per month. So for a terabyte, I did the calculation for you. For a terabyte, it's about $86 a year. And think of it as really replacing your VTL or your tape libraries. So there's a number of features available within Glacier. You know, you have vault inventory, so you can get basically an inventory of what is in your vault, all of those different archives. Again, very easy to use. Like S3, we give you access to the SDKs, APIs, management console, and even an AWS CLI. There are data retrieval policies you can set up. So you can set it up where you only want to access data that you can access freely a month, which is you know, up to 5% of your data you can access without being charged a data access fee. You can also have access controls that you can set up, and it's integrated with AWS Identity and Access Management, and it also supports MFA delete, as does S3. It integrates with the lifecycle management policies, and it also supports tagging as well. So some of the features that we have within Glacier: vault lock, audit logs, and vault access policy. So we're really able to lock down your data. Think of it as you know, creating your data as immutable objects, which is really write once, read many. And you can set it up with a vault lock, where once you set that up and you set the policy for that lockup, you can't change that policy. So it's not like you can delete that object or that policy after the fact. It's always going to be there. So there are different ways to ingest data. You know, we've got the SDKs, we have lifecycle policies, as well as third-party tools. I know we only have about 4 or 5 minutes left, so I want to quickly go through some of our ingest options. You know, we can get data into Amazon S3 and Glacier through using a number of different ways. Direct Connect, which is a single-mode fiber connection into your AWS infrastructure from an on-prem location. Snowball can give you the ability to ingest large amounts of data on a physical device that is shipped from your facility to AWS. We also have, you know, Kinesis. We have S3 acceleration, which we talked about, and storage gateways. CloudFront is our content distribution network, where we have 64 edge locations around the globe, and you can use that to basically move your data or have a cache of your data closer to your end users. So that just makes a better experience for your end users. It lowers the latency, and it's overall, it creates a better user experience for your users. And this is really how it works. Amazon S3 would be the origin of this data, and you'd have your edge locations that would serve out the contents of your bucket through this network. So we only have a couple minutes left. There's a couple of case studies that I just wanted to mention. You can go online and take a look at these. SoundCloud is a great case study. They use S3 and Glacier today to store the data, the audio files that their artists and their customers upload into the cloud. And Druva is sort of an enterprise backup solution that is built on top of the AWS infrastructure. We have a large partner ecosystem. These are just some of the partners we have available today in the different areas. And here are some of the links that if you wanted to learn more about Amazon Glacier or Amazon S3, some of the pricing information, and we have a YouTube channel that has some great videos on S3 and Glacier. So you know, I encourage you to click on these links and find out more information about our storage platforms.
And again, I'd like to extend a special thank you to Daryl for his time and the great presentation today. And thanks for Lexley and Peter for answering all our questions throughout the session. We had a lot of questions come in, so that was great to see, and thank you for that. If you have any comments on our previous or upcoming webinars or suggestions on topics you wish AWS to cover in future webinars, please feel free to email us at aws-webcast@amazon.com. Your feedback will help us improve our webinar programming. So thanks to our audience today for taking the time to join us. Have a great rest of your day.